Okay, so over on the notes page, we already covered the part where we do sine, cosine, and tangent on the angles, right? But any operation, and these are just operations in math, right? Like addition, subtraction, multiplication, division, square root, squaring, right? So they're just another operation. Every operation in math, you may have noticed, has an operation that undoes it, like an inverse operation, right? So when you're solving an equation and you got x plus 2 equals whatever, what do you do to both sides? Subtract 2. Because why? Subtracting 2 is the inverse of what? It undoes it, doesn't it? Right? And you're off with just what? X. What is the inverse of multiplying? Dividing. Right? It undoes the multiplying. What's the inverse of squaring? Taking the square root, right? They're both inverses of each other. They undo each other, right? And you're left with just the x, the variable. Right? Makes sense? Well, sine, cosine, and tangent also have their inverses. It's pretty simple. It's called inverse sine, inverse cosine, and inverse tangent. So if I take the sine of an angle, how do I undo taking the sine of it? Well, I take the inverse sine. Okay? So if you look down here, right? Inverse trig functions. Here's the notation, by the way. You got to be careful because that -1 in the exponent does not have a numerical value. It's not to the -1 power. So it's just notation that means inverse sine, right? Inverse cosine, inverse tangent. Please, I just told you that. Don't anybody ever tell me that it's sine to the -1. Okay? It is not to the -1 exponent. It's just notation. All right? Am I recording here? Yes, I am. Okay. So what is this one called? Inverse. And this one is inverse. Just say it. And inverse tangent. Those functions undo sine, cosine, and tangent. Just like subtraction undoes what? Addition. And you're left with just a variable, right? So if I'm taking the sine of, now our variable state instead of x, right? I'm taking the sine of theta, and I want to know what the actual theta, the measure of the angle is. How do I undo taking sine? I take the what? What's this? So this is the inverse sine of the sine of theta, and what's left? I've just undone the sine. You get the idea? It's like 5x. Okay, then divided by 5, what's left? X. Does that make sense? If I'm taking the cosine of theta, and I want to get the theta by itself, what do? Take the inverse cosine of the cosine of theta, and what will the result be? Theta. If I'm taking the tangent of theta, and I want to get that theta by itself again, I take the what?
Inverse of tangent.
So the inverse, it's just inverse tangent, right? Just call it inverse tangent of the tangent of theta. Just gives you your theta, right? So it's like if I have x squared and I want to get x, what do? What undoes squaring? What undoes squaring? Square root. What's the square root of x squared? X. Right? What's the inverse sine of the sine of x? What's the inverse sine of the sine of x? X. But, you know, usually we use a theta instead of x, right? Because they're angles, so we'll let that get you off one. Okay? So let's go back now and see how we might be able to use these now to find missing angles using trigonometry. So we're probably going to know some side lengths and the ratios, and now we're going to find the angles. Right? And by the way, it's important to know, inverse trig functions always give a what?
Angle measure.
An angle measure. Okay? And by the way, you only take sine, cosine, and tangent of angles, not side lengths. Okay? You never take the sine, cosine, and tangent of 5. It doesn't make any sense. Like the side length is 5. Only of angles, and we undo with inverse trig. So, oh, did that one. So we're right here. Now, what are we missing? What is it we want to find out?
Theta.
The measure of that angle, theta. Okay, think of it as just an x, right? Just an x, just a variable. They gave us the what? What's that 13?
Small length.
Opposite. Well, in this case, we'll think of opposite, and the 34 is what? Okay, that gives us our equation. What's the equation? If they gave us that angle, reference angle, Opposite and adjacent. What's our equation?
10.
Tangent of, what's the equation? Tangent of theta equals
13 over 14.
opposite over adjacent. Now,
Wait, yeah, why'd you get 14?
oh, that's a typo.
That is a typo.
That's a 34. Sorry, guys. It's right down here. I'll make a note of that. So 13 over 34, right? But listen, I don't want tan theta. I want just what theta is. Okay? So how do I undo taking the tangent of theta?
Multiply by 13.
Multiply by what?
13.
No.
34.
No.
No.
Inverse tangent.
I take the inverse tangent of the tangent of theta. But, as always, if I do something to one side of the equation, what do I then have to do? Do it to the other side. So if I take the inverse tangent of this side, I have to take the inverse tangent of 13 over 34. What's the inverse tangent of the tangent of theta? Theta. Now, on your calculators, you see where it says sine, cosine, and tangent? Do you see just above it, not the button above it, but right above it? What does it say?
And negative 1 here.
No, not -1. Inverse sine, inverse cosine, inverse tangent. Huh? So what you'll do now is push second, inverse tangent, parentheses, 13 divided by 34. Close your parentheses. Make sure you close them, and then hit enter. What do you? Well, in this case, it won't bother anything, but a lot of times it will make a big difference if you don't close them.
20.92. 20.9.
20.92 degrees. So you see, we didn't have any angles in here, but we had two side lengths, and we can find the angle. Let's look at the next one. Here's our reference angle theta. 25 is what to it? What side?
Adjacent.
Adjacent. 32 is what? Hypotenuse. Which trig? Yes. Cosine is opposite over or adjacent over hypotenuse, right? So what's our equation? Cosine of what? Theta equals what over what?
Adjacent over
Whatever that adjacent. Yeah, get it now? Okay. But again, I want theta, so I've got to undo taking cosine. So what do I use?
inverse.
Inverse cosine of both sides, right? Inverse cosine of the cosine of theta is going to equal the inverse cosine of 25 over 32. What's the inverse cosine of the cosine of theta? Theta. Calculators, inverse cosine of 25 over 32. Make sure you can get that. Everybody do it. Inverse cosine 25 over 32. Everybody get 38.62?
Yep.
Trying to get this now? So if you want to find an angle measure with trig, you have to use what? What kind of functions?
Cos, tan.
Inverse of those. It's called sine, cosine, tangent. Okay? What's the inverse of those? All right, here's one more. Here's our reference angle theta. This 22 is what side to that angle? Opposite. And the 34 is what? Which trig function will be our equation? Sine. What's the equation? Sine of what? Sine of theta equals opposite 22 over hypotenuse 34. You see why you know how to pick sine? You getting that? Like why we pick sine here and cosine here? Because they gave us opposite and hypotenuse, and you can flip back and put, okay, SOHCAHTOA or whatever, and that's your equation, right? Okay, how do I undo taking the sine of theta? Because I want it out of there. What's that? Inverse sine, not negative nothing, okay? Inverse sine of both sides. Inverse sine of the sine of theta is theta, just like 5x divided by x is x, right? And everyone right now do inverse sine of 22 divided by 34. Close your parentheses. Get used to it. Even though it doesn't matter right now, it will make a big difference later. Is everyone able to get 40.32? Follow me? Okay. All right. So let's go down here. I'm going to give you a minute to solve each one of these, 4, 5, and 6. Okay? There you go. 1, 2, and 3. Weird. What was 1, 2, and 3? Oh, I jumbled this around into big number stuff. Whatever. Okay, so just try. I want you to Make it look, hey, guys, it's gonna look like this stuff, okay? You don't have to write this, right? I want you to start with whatever your equation is, whether it looks like that, right? Or looks like this. You don't need this, okay? That's what your work should look like. Everybody got me? Set up an equation based on what they gave you. Now let's see if we can solve number 4 for this missing side. Give me a moment. So it's 13.48. So your equation depends on what they gave you. Here's the angle. This x over here is what side to that reference angle? Adjacent. And this 15 is the what?
A hypotenuse.
Hypotenuse. Which trig function uses adjacent over hypotenuse?
Cos.
What is it called?
Cosine.
Cosine. So what's our equation? What's the equation, guys? 26 degrees equals x over 15. Right?
X over 15.
No, you can't. Why would you put that in there? You don't have a value for x. What's it going to do? Well, just like, so let's just say, listen, instead of cosine of 26, what if I just said 115 equals x over 15? What do I do to both sides? Multiply by what? I'll do it down here so this doesn't confuse anybody. So I'm going to take 15 times the cosine of 26 degrees equals x over 15 times 15. See, I'm just multiplying both sides by 15. This is algebra. These cancel. So x equals 15 times the cosine of 26. What did we see your calculator said? 13.48 centimeters. Okay? All right, try number 5. Your equation is going to depend on what they give you. The function you pick. I can't hear you. Well, I thought you were taking a sine. You mean the sine of 56, right? Yeah. So sine of 56 degrees equals what over what?
Why is it 10?
Well, what tan is opposite over adjacent? That's why.
Why isn't it close?
What is cosine? Adjacent.
Wait, but
We've got opposite and hypotenuse. For to use cosine, they'd have to give you that one and that one, right?
Center.
Because this is the opposite of that angle, and this is the hypotenuse. So what do we do to both sides? So 12 sine 56 degrees equals x over 12 times 12. They cancel. What do you get?
X equals 12 times sine 50.
Yeah, what do you get?
7, 9.
Yeah, why is it? And it's x equals approximately, not 17,
I got 9.
9.95 centimeters. Okay? Anybody give me the equation in number 6? Or just which trig function we're going to use? Y tangent, because they gave us that 4 is the what? Opposite, and they gave us this 5, which is what? So that's tangent. So what's the equation?
Data.
4 over 5. Well, this time we're solving for theta, right? What are we going to use to get the theta out of there? Inverse what? There you go. I'll give you a second. So I'm trying to solve for the angle measure, so I have to use inverse tangent, right?
38.6.
Inverse tangent of the tangent of theta. Same to both sides. 4 over 5. What's the inverse tangent of the tangent of theta? Theta. Now you go to your calculator. What's the inverse tangent of 4 divided by 5? Close parentheses. You keep forgetting to do that. We got it because we're rounding, right? So equals approximately 38.66. What are our units? No, Inverse trig always gives an angle. We're in degrees. Okay? Couple more on the other page here. Let's see if we can hack through these.
I did not know.
Well, by the time you get done with these, hopefully you will. So listen, whether you use sine, cosine, or tangent for your equation just depends on what they've given you in the picture. If they gave you opposite side and adjacent side, you're using tangent. How do you know that? Because you know so God told us, or whatever it is, right? Okay? Oops, let's record that. So what do I do to both sides now, everybody? Take the inverse what? What? Sine, cosine, or tangent? Yeah, okay. So inverse sine of the sine of theta. And we do the same to both sides, right? What's the inverse sine of the sine of theta, Evan? Let it go over here. What's the inverse sine of the sine of theta? That's what we're going to do. That's like having 5x. Dividing it by 5, what's left?
X.
X, right? That's all you're doing here. Well, kind of. So theta equals approximately what? 2 decimals. On your calculator, the sine it. 58 point what? Round it correctly.
58.12.
How do you go from 0.99 to 0.10?
It's
59.00. Right? 59.00. Units are what?
degree.
Degrees. There you go.
I don't understand that.
What part are you missing?
How do you put it in the calculator?
Do you see the button that says sine?
Yeah.
What's it say right above it?
The sine minus 1.
What do we call that? Inverse sine. Second sine. Do it right now. That's why I had you guys do it earlier.
Sine.
So your screen should say inverse sine, put 12 divided by 14 and close your parentheses in there. What'd you get?
I got 58.9.
0.9 what?
9. So 59.00.
59.00. There you got it.
There we go. I got this.
Ms. Bernatavitz, what trig function are we using for 8? Well, let's figure out. Here's our angle.
Opposite and
Wait a minute. Shh. What's that x to that angle? Opposite, adjacent, or hypotenuse?
That's still hypotenuse.
That's the hypotenuse. Hypotenuse across from the right angle. What is that side? Don't tell them. Turn around. Turn around. That is not adjacent. It's across from it. So we call it what?
opposite.
Opposite. What is this for that they gave us in relation to that reference angle? It's next to it, so we call it what?
You already said it.
It's either opposite, adjacent, or hypotenuse. Which one of those words means next to it? Of the 3 words, opposite, adjacent, and hypotenuse, which one means next to it? Adjacent.
Let's go.
You did it, man.
So which trig function uses opposite over adjacent? You look up here now, so put it up here. Quiet, don't tell them. Which one uses opposite and adjacent? Tangent. So what's the equation? Tangent of what? Tangent of what? What do they always take the sine, cosine, and tangent of? An angle. So tangent of what? No, Bernatavitz. Tangent of what? You see an angle in there? Tangent of 42 degrees equals opposite over adjacent. So what over what? Opposite over adjacent. X over what? 4. There you go. That's it. Well, now you solve it.
How do we do that?
Just put it in the calculator.
How do you ever solve for X when it's being divided by 4? It is being divided by 4. What's the opposite? What's the inverse of that? What's the opposite? Multiply both sides by?
See, it's fine with that.
What's x equal to number 8? 3.60. How many got that? Centimeters, right?
You got time for next stuff.
One more to go.
Oh, so you multiply 4 by. Or,
Whatever you do on one side, you always do the other. One more to go. Ashton Croft, what trig function are you going to use for number 9? Okay. Here's our angle. What's this side to that angle? That's adjacent. They gave us the x here. What is that side of the triangle?
Oh, hypotenuse.
Hypotenuse. Which trig function uses adjacent hypotenuse? No. No. It's right there.
Oh,
Cosine. So what's your equation?
cosine
Well, they gave us a number. Of what? 50 degrees equals,
x over 8.
it's adjacent over hypotenuse.
8 over
8 over x. That's how you get the equation. Hey, this is the one with x in the
wait,
bottom.
so it's not sin.
Why would it be sine?
Weird.
Don't call it sine. Sine is opposite. Hey, here's our angle. That would be the opposite side to this angle. They didn't give us anything. They gave us the value for the adjacent and the hypotenuse.
Oh,
Who remembers what to do here for x is in the bottom, guys?
Switch up.
We can just switch these two things here.
no.
So that gives us what? X equals 8 over, no, cosine 50. Why would you drop the cosine? The whole thing.
That's weird. That's goofy.
That's division, yeah.
So do you put 8 divided by?
Well, if I said that's division, then it would have to be 8 divided by.
X equals
Make next
12.45.
12.45 centimeters.
Yeah.
45. 8 divided by cosine of 50.
I got 12.
Okay, what did you do this way?
Well, I basically did what you did after like 1.
There's a lot of
Just tell me what you wrote.
Say that.
First thing you wrote down.
That's the waves.
Yeah.
There's a lot.
Right.
I wrote cosine. Well, I did just don't know. I did cosine. And then I put 60.
There's that, Paul.
I guess same.
I got something you did. What is?
Ashton, keep your mask on.